Okay, this is day one of topic 1A, lesson 1, parent functions. Okay, which we're going to start today. There's no homework, so what is today? The 2nd of September. So I like to put the date. Can everybody see it or no? I wanted to make sure that some of you that came in tardy, that, I'm glad you're here, that Unit 0, I said I would take grades up to the test. Well, we're not going to have any more tests from it, correct? Anymore. So Friday will be the last day that you can turn in stuff from there, and I'm going to zero anything out that you haven't done. Does that make sense? Okay? All right. I try to do a better job communicating. Okay, so let's graph these points here. So we got -2, -2, 1, -1, 1, 2, 3, 4, 0, 5, 1, 4, and 2, 1. Okay? Starting this now, you put that away. Glad you're here. Okay, so if we draw our graph, looks something like this. Okay, does anybody know what that thing is? It's a parabola. It's a U-shaped graph. It's a quadratic, which means it's an x squared. Great. Okay. All right, let's do this other one here. -2, 20, -1, 10, 0, 5. Does anybody know what this point is here that's intersecting the y-axis? It's called the y-intercept, isn't it? So anytime the graph intersects the y-axis, it's the y-intercept. That's where x is 0. Then 1, 2.5, and then 2, 1.25. Okay? So this thing's going something like this. And notice that thing will never cross at x equals 2 right here. Excuse me, y equals 2. Okay? Anybody know what this thing here is? Exponential. Yeah, it's an exponential. In fact, since it's decreasing from left to right, it's called an exponential decay. Okay, hopefully you have an exponential growth where your money goes up, right? Okay? All right. Then the next one, let's graph it, -2, 11, -1, 8, 0, 5, 1, 2, and 2, -1. Okay? Anybody know what that is? Like to me, it's a line, isn't it? Get my rulers out. Okay. Then the next one, -2, 2, -1, 1, 0, 0, 1, 1, 2, 2. So it looks like this. You may know what that is a graph of. Well, we just did a bunch of absolute value equations, didn't we? That's an absolute value equation. Anytime I get a V-shaped graph, that's an absolute value. Okay? Now let's talk about the differences. Describe the differences in the graph. Well, I think they all have different shape, don't they? Correct? Different shape. As I look at going from negative infinity to infinity, this graph here, the y values are decreasing, aren't they? As I go from left to right. Here, as I go to left to right, the y values increase, and then when I hit there, what do they do on the other side? They decrease. So increase the y values, decrease here, correct? Here, from left to right, the whole time the y values are doing what as I go from left to right? They decrease, correct? They get smaller. Over here, as I go from negative infinity to 0, they decrease. And then from 0 to positive infinity, they increase, don't they? You understand, negative infinity to 0. I'm talking about the x. The y's are getting smaller. From 0 to positive infinity for the x, the y values are increasing. So they have different increasing, decreasing. Okay, given based on the points, based on the given points, give a reasonable domain. Okay, the domain are which values, x or y? The domain is always the x values, isn't it? Think about this. D comes before R, x comes before y. So the domain values, everybody agree with me, I can put whatever I want in for x. There's no restrictions on x. So the domain for the x values, the domain is all real numbers. There's no restrictions on the variables. Now let's talk about the range, which is different for each one. Let's look at this first one here. The range of the y values. And the range, you always go floor to ceiling. So look at this one here. What's the floor? What are those arrows pointed towards? Negative infinities down here, positive infinities out here. So the range for this one here would be negative infinity to 5. Floor to ceiling. So is it ever going to go above 5 for y? No. So your range for this one here, for the parabola, is negative infinity to 5. You could also say y are all values less than or equal to 5 as an inequality. Okay? Now let's look at the range of, see here, let's look at the range for this one here. Again, the domain is all real numbers, so the range for this one here, floor to ceiling. So is this thing ever going to cross 2? No, so it's going to be 2 non-included to positive infinity. This graph, this exponential will get really, really close to that line y equals 2 but never cross it. That will end up being called an asymptote. And what's the ceiling? Where's the arrow pointed at? Positive infinity. You could also say y is greater than 2, because 2 is non-included. Okay, the range for the line. Well, floor, which way? Floor is down here, which is negative infinity. Positive infinity is up here. Well, what's the arrow pointed towards? Negative infinity. And what's the arrow for that one pointed towards? Positive infinity. So this one here's all real numbers. The range for the line is, both of them are positive, are all real numbers. The x values and the y values. All real numbers. And then the last one, which is the parabola, the absolute value function. Again, the domain's all real numbers for all of them. What's the floor here? What's y here? 0, and it's included. And then it's going towards positive infinity. So this one here would be y is greater than or equal to 0 as a inequality. Okay? Okay, so the equation for a linear is y equals x. Y equals x. So if I plug in -3 for x, what do I get for y? -3. So these are all going to be the same values. Whatever I put in for x, I'm going to get the same thing for y, correct? So if we graph this thing, 0, 0, 1, 1, 2, 2, 3, 3, then -1, -1, -2, -2, and then I draw my line, correct? Which should look like that. The domain, again, is all real numbers. And the range is also all real numbers. And again, what is this thing? It's a straight line. Quadratic is y equals x squared. Okay? Quadratic, x to the second power. So let's graph this. What's -3 squared? What's -3 times -3? 9. What's -2 times -2? 4. What's -1 times -1? 1. 0 squared, 0. Then 1 squared is 1, 2 squared is 4, 3 squared is 9. Okay, so let's graph this one here. -3, 9. -2, 4. -1, 1. 0, 0. It looks like this. Yeah, it's Y-shaped, isn't it? It's not Y-shaped, Donnie. U-shaped. U-shaped. Okay, so what's the domain? Is there anything I can't put in for x? No, it's all real numbers. Negative infinity to infinity, all reals. The range is floor. What's the floor? What's the small? 0, correct? Included. And then the ceiling's what? Positive infinity. Infinities are never, okay? That's not a very good U shape there. There we go. Okay, cubic. Is y equals x cubed. So negative 3 cubed is negative 27. Y is negative 3 times negative 3 times negative 3 will give me negative 27. Negative 2 cubed, well, negative 2 times negative 2 times negative 2 is negative 8. Negative 1 times negative 1 times negative 1 is negative 1. 0 cubed is 0. 1 cubed is 1. 2 cubed is 8. 3 cubed is 27. So if we graph this thing, 0, 0, 1, 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. Negative 1, negative 1, negative 2, 8. So it looks like this. S-shaped looking graph. So can anybody tell me the domain again? They're always going to be what? All real numbers, correct? What's the range? Well, the arrow's pointed down where? Towards what? What's that thing pointed down towards? Negative infinity. And what's the ceiling? What's it also pointed towards? Infinity. Okay? These are all what's called the parent functions, where we start from, okay? Everybody have this? Okay, absolute value function is y equals absolute value of x. So negative 3 gives me positive 3. Negative 2 gives me 2. Negative 1 gives me 1. 0, 1, 2, because the absolute value of any number is a positive, correct? Because absolute value means what? Distance from 0. Agreed? So 0, 0, 1, 1, 2, 2, 3, 3, negative 1, 1, negative 2, 2, negative 3, 3. So we get a V-shaped looking graph. Agreed? Like that. Again, the domain for these functions are always all real numbers. Okay? Range, floor. What's the floor? 0, included, because there's a point on it. And the arrows are pointed towards what? What's the ceiling? Positive infinity. Okay? And again, notes about this one here is V-shaped. Okay? Exponential. Y equals base b to the x. An example for that one there would be y equals 2 to the x. Okay, so we're going to use 2 to the x as our example when we graph it, okay? All right, so how many remember what 2 to the negative third power is? 1/8. Means 1 over 2 cubed, okay? Negative exponent, agreed? Then 1 over 2 squared would be what? 1/4. 1/2. Okay? 2 to the 0 power. Anything to the 0 power is equal to what? 0 or 1? Anything to the 0 power is equal to 1. 2 to the first is 2. 2 squared is 4. 2 to the cube, 2 cubed is 8. Okay? So let's graph it. 0, 1. Negative 1, a half. Negative 2, a fourth. Negative 3, an eighth. So you guys see it's getting really, really close to the x-axis, isn't it? Will it ever touch the x-axis? No, it will not. Then we put 1, 2, 2, 4, 3, 1, 2, 3, 8. So it looks like this. It's increasing from left to right. So again, my domain is all real numbers. My range is 4. What's the floor? Is it ever going to cross y equals 0? So it's going to be 0, non-included, to the ceiling, which is positive infinity. Notes, you're going to hear this a little bit. We will have an asymptote at y equals 0. What I mean is this graph is going to get so close to the line y equals 0 right here, this horizontal line, it almost looks like it, but it really doesn't ever touch it, okay? What is that? Who knows? Okay, everybody have that? We okay? If you don't understand it, if right now conceptually you don't understand it, then you got to memorize. Because I've said this a long time. When I was a sophomore, if I'd have taken Algebra 2, I would have failed. Was I not very bright? That's not true. I was pretty bright. He said, just conceptually as a sophomore, I couldn't understand the concepts at that age. Same way with Algebra 1 as a freshman in high school. I couldn't understand how 2x times 3x gave you 6x squared. Where'd that 2 come from above the x? Conceptually, I couldn't picture it. Give me one more year and I was okay. Does that make sense? So if you struggle right now, that's okay. That doesn't mean you're not smart. It just means that at this time, your brain develops in the front. Everybody develops differently, okay? A year from now, so when you don't understand it, you just got to do it and just memorize it. And a year from now, you'll understand it. You guys are staying away, okay? All right, square root function, okay? Square root function. Okay, remember, you cannot take the square root of a negative number. So, what's the square root of 0? 0, correct? What's the square root of 1? 1. What's the square root of 4? 2. What's the square root of 9? 3. What's the square root of 16? 4. What's the square root of 25? 5. And then what's the square root of 36? 6. You cannot take the square root of a negative value. So your domain this time is 0 included to positive infinity. You cannot, that means they have to be positive. Your range, just graph this thing, 0, 0, 1, 1, 1, 2, 3, 4, 2, 9, 3. It looks like this, half of a C. So the range on this one here is also 0 to positive infinity. And remember, you can't square root negative numbers. Last one. Y equals the cubic root of x. Okay? On this one here, you can take the cube root of negatives. You just can't take the square root of negatives, okay? So the cube root of negative 27 is negative 3. The cube root of negative 8 is negative 2. The cube root of negative 1 is negative 1. The cubic root of 0, of course, is 0. The cubic root of positive 1 is 1. The cubic root of 8 is 2. And the cubic root of 27 is positive 3. So let me show you this on your calculator. So go to math, number 4, get negative 27, and I get negative 3. Go math, number 4, cubic root of positive 27 is positive 3, correct? But look at this. If I take the square root of negative 16, look what happens. Can't do that, can I? Does everybody hear what I just said? You cannot take the square root of a negative number. Eventually, we'll do that when we get into imaginary numbers. But right now, cannot do that in a real number system. Does everybody hear what I just said? Does everybody see how to find the cubic root on your calculator? Go to math, number 4. Negative 27, hit equals, and I get negative 3. Okay. The domain of this one here, of course, you can use whatever you want for x. The range is also all real numbers. Let's graph it. Negative 27 is off the page. And we can do negative 8. Negative 8, negative 2 is right here. Negative 1 is right here. 0, 0 is right here. 1, 1 is right here. 8, 2 is right here. So it looks like this. I'll flatten down S. Negatives are okay on this one. Okay? These are the ones we're going to be working on. So tomorrow we'll come in and we'll start in